Howdy, AP PreCal. It is Ms. Kosh. We are now looking at Mr. Passwater's notes from section 1.2. So he updated that for us this year, which is fantastic. Okay, so in 1.1 we learned that rate of change and slope are the same thing. And so if it has a positive slope, the function is increasing. A negative rate of change indicates it has a negative slope, the function is decreasing. He has here, in AP PreCal, we will define the rate of change of a function at a point as the rate which the output values would change if the input values were to change at that point. Okay, later we're going to call it, in AP Calc, we're going to call that the instantaneous rate of change, but we are not ready for that yet, so, and anyway, there we go. Let's see. If the car you're riding is going up, then the function has a positive rate of change at that point. If you're going down, then the negative rate of change at that point. Okay, so we can think of, I kind of did this in my last video, where we have this little tangent line. It's got a positive slope. Here's a slope of 0, and then here he has a negative slope. He's going down. At T1, the rate of change is positive. At T2, the rate of change is 0. At T3, the rate of change is negative. Okay. What does this say? The fastest roller coaster? Oh my, no thank you. I'm a wimp. Comment below, would you want to ride this roller coaster? Or comment below, have you ridden this roller coaster? If you have, I'll just be blown away. But no. Okay, sorry. I think I got old. I don't know how that happens. All right, we're still gonna have fun. Okay, the figure shows the graph of the function in the XY plane with 3 labeled points. Order the rates of change. Okay, so here this has a positive, so A's rate of change is positive, B's rate of change is negative, and C's rate of change is 0, because this is right here. So what did they ask us to do? To go from the least, well, the negative would be the least, the 0 would be next, and then the positive would be the most. Okay, the figure shows the graph of the function g with 4 labeled points. Of the following points, what's the rate of change? Oh, at which is the rate of change the least? Okay, so what do we have here? We've got, this is concave down. Here we are concave, okay. Our graph is increasing. I think maybe B might be that inflection point. But it's got a positive slope here at A. It's got a positive slope at B. C has a negative slope, but D is even more negative. So if you think about, say this is the concave down part, the average rate of change is decreasing when it's concave down. So if the average rate of change here at C is going to be bigger than this because it decreased on its way down. So the answer is D. Okay, average rate of change. We're going to talk more about this in 1.3. He tells us, what else do we need to see? You can pause this and read everything he wrote. Okay, the figure, which of the following interval is the average rate of change the greatest? Okay, so from 2 to 3, that between those 2 points, the change in the y value is 0. So that one is the average rate of change would equal 0. From 3 is here to 5. Where's 5? Okay, so going here, that is negative. We may have to come back and be more precise in a second. From 5 to 7, is this 7 right here? That is a positive average rate of change. So what did they ask us? The greatest, so far the positive is bigger than the other two. 7 to 8, 7 is this point, 8 is, where is 8? Maybe here? Maybe here? That's also a negative rate of change. So the positive one, so we were able to do that problem without actually doing any, using any numbers. We did math, but we didn't use numbers. Okay, I'm happy with that. Okay, the next one, let's see. Oh, hey, this is the last page of 1.2. The graph of the function in the xy plane has a negative rate of change. Okay, so negative rate of change means that the graph is decreasing. Which of the following definitions for variables x and y would best model the function f? I haven't looked at this yet. Okay. X in the age and years of a young child, y the height. No, because you would be, as you get older, your height gets taller, right? So your y value will be increasing, not decreasing. X, the total number of points scored in a basketball game, versus y, the time remaining. As you score more points, yeah, the time, like the like you're not going to start a game and have fewer points. Okay, this is score, and this is time. What time you have at time, hang on just a second, X the total number of points. So I've scored 0 points at time 0, and I score time remaining. Oh, okay. So hang on. I've scored 0 points at time 0, but it's not time, it's the time remaining. Okay, so I don't feel like writing it out. At the beginning of the game, I have a whole lot of time remaining. And so yes, this is my intuition. Let's see, which of the following would best model that? The time in seconds since a ball was thrown straight up in the air, the height in feet of the ball. No, when you throw a ball, it goes like that. So its average rate of change with this, when it's concave down, its average rate of change will be decreasing. But first, the function has a positive rate of change, then it has a negative rate of change. The change in the rate of change is, okay, hang on. I may be confusing myself. But this graph is not always decreasing. First it has to increase, then decrease. Okay, the radius in meters of a circle and the area is square inches of the circle. So if the radius increases, the area is going to also increase. So that's not going to be correct. So I'm still happy with our answer B. Okay, guess what we need? We need a calculator. What was I doing last? Who knows? Okay, let's come to this graph. Which of the following statements is correct? Let's type this mess in. Okay, even without the calculator, I can tell that it's a parabola that's going to open down because I only have, my largest variable is x squared, and it's got a negative leading coefficient. So can I answer these? It has a positive rate of change. No, I need to know where it's increasing and decreasing, so I need to know the maximum of this. So using my Casio, I will come here and type this mess in. This is a gross problem. I love it. No, I'm just kidding. It's fine, it's fine. Okay, so here's our equation. I'm gonna set my window to the standard window just to, I don't know what's gonna work. Oh, that worked, okay. I like to adjust the window as opposed to zooming in and out, but you do you. I mean, in that regard. Okay, I hate you do you. It drives me crazy, but be the best version of you. Don't just settle for you. Okay, never mind. Okay, so our x value, we need to not use this because when we're talking intervals, we're not talking about the y value at all. So anything that has this 8.3, that's a distractor. So don't use that 8.3. So we need this. Okay, so let's see. From 2.47 is 0, that's this. It has a negative rate of change over the interval of 2.47 to 10, sure, because it's decreasing. So negative 10 to positive 2.47 no, it would be positive on that one. Could you see all that? I hope so. I'm sorry. Okay, let's see this next one. What is the average rate of change in life? When is the average rate of change in life expectancy the greatest? Well, do you know what we might do with this one? You could either, we're going to talk in the next part, or I've already talked in some of my notes, but what you're doing to find the average rate of change, you would call this function f of that's not 150, of 1850 minus f of 1800 divided by 1850 minus 1800. And then you could find the average rate of change in each of these intervals using the formula, or I could come here and come to my, statistics. I could type these in, and then here's my x value, and my x value, and my x value, and we have a bigger, I don't have a bigger jump. I just didn't look in the right spot. Okay, I thought we were jumping to 2000. Now we are. Okay, and then I can plug in my x values for, if I make a mistake, you can't even see my table. I'm so sorry. Help me make sure I'm right. That will change everything if I type it in wrong, so comment below if I make a mistake. Life's too short for me to care right now. I mean, what? Okay. That's wrong. That's wrong. Okay. Let's graph these points. So my average rate of change here is kind of shallow. It's a little steeper. It's more steep. It's less steep. So I would guess it's probably these two. So this was 1800, 1850, 1900, 1950 to that. So I think this is the most steep. So what did I say, 19 to 1950? Yeah, I mean, they told you to use a calculator. I guess we could. All of these are, okay, they're all 50 years apart, so we just really need to figure out. So if I come back to my regular screen, I can do 46.1 divided, what am I doing? Subtracting 41.24. Okay, so this is the numerator, and it's going to be divided by 50. Okay, but they all have the same denominator. So let's see, 53.63, that's not a 3. Minus 46.1. Okay, that is a bigger numerator over the same denominator. And then I have 70.65 minus 53.63. That's the biggest numerator that we've seen. This numerator is going to be about 11. I don't know why I needed a calculator. Okay, so my intuition from the graph was correct. Now, I didn't find the average rate of change because I forgot to, I intentionally didn't divide by 50, but each of those numbers would be divided by 50. All right, that is the end of 1-2. So come back, like, subscribe, comment down below. Let me know how this is going for you. Good luck.